So today I will be talking about the method of sections way of solving for the forces on a truss. So I've done a little bit of the just kind of setup work so it doesn't take quite so long, but we're looking at this truss here. There's a wall here, and with the method of sections, we can cut our truss so we don't have to deal with forces on the wall that we don't know. So in the problem, you're asked to find FC, FE, and BC. So FE, FC, and BC. So I decided I will cut along each of those to get just this half, so now we don't have to worry about the wall. I did include all of BC, FC, and FE, even though I technically cut it here, just so it's a little easier, especially when we're summing the moments around F to kind of see what's going on, and when we're figuring out which way if these trusses are compressing or if there's compression or tension on each of the points. So to start, I drew my diagram, and then I figured out which way, so if I had tension or compression on each of these points, just to get an idea of what forces I would have. And it really shouldn't matter. If you say if this force was supposed to be tension on C and it was actually compression, like it is, or if it was tension and it's supposed to be compression, which is supposed to be compression, then you would just get a negative number for that, and you would figure out, okay, I did that wrong. So it's not a huge deal as long as you're consistent. But so to kind of explain that, we have our 500-pound force pulling down, and the only way that we can kind of counteract that so this doesn't just fall over is if ED has tension. So I'm actually going to label that tension. So that means that the truss is providing tension there, so it's also providing tension here, which means FE is providing tension on this. So there's tension there. And then same thing here, we've got this joint, or I guess we have EC that could provide a vertical, but FC is also taking some of that vertical, so that's a compression, or a tension, sorry. And then we need something to kind of counteract all the pulling we're doing, so that means BC is under compression. So those are just the three that we really care about, FE, BC, and FC. Just a little bit of kind of understanding what's going on with the truss there. So the next thing we need to figure out is how we're going to solve for our forces. We have three unknowns. We have FE, we have BC, and we have FC. But we do have a lot of known. We have at least two knowns, and we can kind of figure out what's going on with that. So the way that I decided to do this was we have three unknowns, so I'm going to need three equations. And in this case, it works really well to use the sum of moments around different points, since we have a lot of information about what's happening at different points, as well as we know all the distances to points. So I started off with the sum of the moments around D, just because D would include all three of them then. None of these are going through D, obviously, because there's no D in any of the names. So I decided to start with that. So the first thing that would be providing a moment around point D here is this 400-pound force. I'm also eliminating this force, which helps a little bit. It is a known, but sometimes it's just nice to simplify things and get them all into one equation to start. So this 400-pound force so this is this part, it's 400 pounds acting at 4 feet. I forgot to put feet in there. It's acting at 4 feet. That will cause it to rotate this way, counterclockwise, which will mean it's a positive moment. So that's positive. And then we've got FE next, which is also acting in a positive moment. So it'll be pulling this way, which will cause it to rotate like that around D, which is counterclockwise. That's also positive. Our final one that is acting is FC, and FC is a little bit more complicated. We had to solve for the ratio. So this 5.6 came from, we know it's 4, but the X is 4, the Y is 4. So 4 squared plus 4, we use our Pythagorean theorem. The square root of 4 squared plus 4 squared gave me 5.66-ish, I believe. Something around there. So we got 5.6 for that. So it'll be FC times 4 over 5.6, because that's the distance to there. And that will all equal 0 because it's not moving. But So now if we go to solve this, we have two unknowns. So we need to couple more, we need at least one more equation to solve this one. So our next one I decided to do is the moments around C, because that will eliminate FC. And we can then solve for FE. It actually eliminates BC and FC, sorry. So we can solve for FE. That isolates that one, because BC is going through that point, so it can't cause a moment. FC is going through that point, so it can't cause a moment. So now thinking about point C, this 400-pound force doesn't matter because it's also going through point C. So point C was a really good one to sum moments around because it eliminates a lot of our variables and a lot of our forces. Point D here, we have this 500-pound force. That will cause a moment, and that will cause a negative moment. So if we have point C and we have a force going like that, it will go this way, which is clockwise, which means it's a negative moment. So that's why it's a negative 500, and it's acting at 4 feet. That's our perpendicular force. So there's that one, and then our other one, which is what we want to solve for, is F of E. So we have F of E, and it's pulling this way. That's why we need to figure out if it was tension or compression. So we know that F of E is going this way, so we've got our point, we've got a force going like that. We're going to get a counterclockwise moment, which is good. That's what we needed, because this is negative, so this needs to be positive. So we have a counterclockwise moment, which would be a positive moment, acting at 4 feet. That's our perpendicular distance, or distance perpendicular to our force, and those will equal 0. So from this one, we can solve for F of E. But we still need to find B of C, or BC, sorry. So I wrote one more moment, and that is the moment around F, because that will eliminate FE and FC while also giving us BC. So we start off with our first one, BC. That is acting this way, we know that, which is it is providing compression on the point C. So that will give us a counterclockwise moment, which means it's positive, and it's acting at 4 feet. And then we've got our 400-pound force here, which is, we have our point B, and we have a force going like this. It's going to rotate clockwise, which means it's a negative moment, acting at 4 feet. And now our 500 pounds, same thing, it's in line with our 400 pounds. It's going to make it go that way. So we got 500 pounds, but this is acting at 4, and then 4 more, so 8. And those all equal 0, because our sum of the moments equals 0. So now we do a little math. So I'll solve this moment first, so we get F of E, and then we can plug it into that, we can solve these. So we will get F of E, oops. Okay, so do a little math here. And to get F of E here, we will just, to get F of E, we're just going to solve this equation. So we know that F of E is equal to negative 500 times 4 divided by 4, and actually, sorry, F of E is equal to positive 500 times 4 divided by 4. We'll have to move one of the two over, and our negatives will cancel. So we'll get 500 foot-pounds, pound-feet, however you want to say it, for F of E. And now let's do B of C, since that one's quick and easy as well. So same thing here. I would probably just move the BC over and make that negative. Divide by 4, and our negatives will cancel. Negative 4. So this is 1,400. Oops, wrong one. Again, pound, feet, foot-pounds, whatever you want to call it. I don't know the right way. And now that we have our FE, we can solve for F of C. So 400 times 4. Plus B is 500 times 4. Alright, and now F of C is we said F of C was negative. So that means, right, f of c is a negative moment around d. Yes, sorry, okay. F of c is a negative moment around d. I was questioning myself there. That is 5,040 foot-pounds. So now we found f of e, f of c, and b of c, and we've answered our question using the method of sections for solving trusses.